In today's video, we're going to go over the world of nanotechnology and how it's changing various industries. Imagine incredibly tiny robots, so small that thousands could fit on the tip of a needle, working on tasks that seem like science fiction, but are closer to reality than you might think. Welcome to the fascinating world of nanorobots. In this video, we'll demystify this complex technology, explain how it works, and explore its potential impacts on our lives. These tiny marvels are set to revolutionize fields like medicine and environmental cleanup. Let's dive in. Don't forget to subscribe to AI Tech Underground for more exciting insights and updates on cutting-edge technologies. So, what is nanotechnology and how does it work? Nanotechnology is a branch of science and engineering that deals with manipulating and using atoms and molecules at an extremely small scale, usually less than 100 nanometers. It involves designing, making, and using structures, devices, and systems with precise control over their properties and functions. By working with matter at this tiny scale, scientists and engineers can create materials with unique characteristics and behaviors. They use various techniques to build these materials, such as bottom-up and top-down approaches, resulting in new materials that have specialized properties different from their larger counterparts. Now, let's talk about nanorobots. What exactly are they? Nanorobots, or nanobots, are tiny machines operating on the nanoscale, often just a few nanometers in size. These microscopic robots are designed to perform specific tasks at the cellular or molecular level, using nanotechnology to manipulate matter on an atomic scale. Nanorobotics, an interdisciplinary field, combines principles from robotics, nanotechnology, and materials science to create and control these tiny robots. It's a relatively new area of study focused on developing and managing robots that work on the nanoscale. Nanorobots have various applications. One major area is disease detection and diagnosis. Equipped with advanced sensors, nanorobots could revolutionize healthcare by detecting and diagnosing diseases early and accurately. These tiny robots can identify specific biomarkers or abnormalities linked to diseases like cancer before symptoms even appear. By analyzing materials at the molecular level, nanorobots provide highly sensitive diagnostic information, enabling early intervention and treatment. For example, in cancer research, nanorobots can be programmed to detect tumor markers or genetic anomalies, searching the body for these indicators and providing real-time information on their presence, location, and concentration, which can lead to early cancer detection and targeted therapies. Nanorobots also have significant potential in manufacturing and assembly. They offer unprecedented precision and control at the nanoscale, enabling the creation of complex structures and devices with enhanced properties. Nanorobots can manipulate and assemble materials at the atomic and molecular levels, allowing for precise positioning of individual building blocks. This level of control makes it possible to fabricate intricate structures previously unattainable with traditional manufacturing methods. By leveraging nanorobots, manufacturers can achieve greater efficiency and quality, as these robots can perform tasks with remarkable precision, reducing defects and improving product consistency. Additionally, nanorobots can help minimize waste by precisely depositing materials and assembling components, optimizing resource use, and enhancing worker safety in manufacturing processes. Another promising application is medical treatment. Nanorobots could transform patient care by performing medical procedures with unprecedented precision. Their small size and mobility allow them to navigate through the human body to reach specific locations with great accuracy. This opens up possibilities for minimally invasive surgeries where nanorobots can access hard-to-reach areas with minimal tissue disruption. One of their significant advantages is targeted drug delivery. Nanorobots can transport medications directly to specific cells or tissues, achieving higher drug concentrations at the desired site and improving treatment efficacy while minimizing side effects. They can also be engineered for various therapeutic tasks, such as selectively destroying cancer cells or delivering anti-cancer drugs precisely to tumors while sparing healthy tissues. Although still in early stages, nanorobots hold immense potential to revolutionize medical treatments. Environmental cleanup is another exciting application of nanorobots. These tiny machines can address pressing pollution and contamination issues, by removing pollutants from water, soil, and air. In water cleanup, nanorobots can target and eliminate contaminants like harmful bacteria, heavy metals, and organic pollutants. They can be designed to bind to and remove these pollutants from water sources, enhancing filtration mechanisms and making water treatment more effective. For soil remediation, nanorobots can remove toxic chemicals, industrial pollutants, pesticides, and chemical residues by breaking them down or encapsulating them for easier removal. In air pollution reduction, nanorobots can capture and neutralize airborne pollutants, including particulate matter, volatile organic compounds, VOCs, and harmful gases. Let's talk about the potential of nanorobots in energy production. These tiny machines could revolutionize how we generate energy and solve major challenges in the industry. By enhancing light absorption, reducing reflection, and optimizing charge separation and transport processes, nanorobots can significantly improve the efficiency and performance of solar cells. They can create nanomaterials tailored for more effective conversion of sunlight into electricity. Nanorobots also hold promise in developing advanced energy storage devices like batteries and supercapacitors. They can manipulate and create nanomaterials to boost energy storage capacities, improve charge-discharge rates, and enhance the longevity and reliability of these devices. Additionally, nanorobots can aid in energy transformation, such as in thermoelectric devices, by improving the conversion of waste heat into energy. By enhancing the thermoelectric properties of materials at the nanoscale, they can increase energy conversion efficiency. Nanorobots also have transformative potential in exploration and sensing. They can venture into challenging and inaccessible areas to provide valuable data and insights. In deep-sea exploration, nanorobots equipped with sensors and imaging capabilities can explore ocean depths, map the ocean floor, study marine life, and gather geological data. Their small size allows them to navigate tight spaces and delicate ecosystems without causing significant disruption. Similarly, in space missions, nanorobots can explore celestial bodies and conduct research in harsh conditions, such as low gravity, radiation, or extreme temperatures. They can traverse difficult terrains, collect samples, and perform experiments, aiding in the exploration of planetary bodies like Mars or the Moon, and searching for resources or signs of life. In material science, nanorobots open up numerous possibilities for creating new materials with unique properties and capabilities. They can be used to develop self-healing materials, smart coatings, and responsive surfaces that adapt to environmental conditions. Self-healing materials, for instance, can use nanorobots to detect and repair damage at the nanoscale. These robots can move through the material, find cracks or defects, and trigger repair processes by releasing healing agents or catalyzing chemical reactions. This self-healing ability extends the lifespan of materials, reduces maintenance, and enhances durability. Smart coatings with embedded nanorobots can change surface properties in response to stimuli like temperature, light, or chemicals. These coatings can exhibit self-cleaning, anti-fouling, anti-corrosion, or anti-icing functions, useful in industries like construction, aerospace, and automotive. That's it for today's video. Don't miss out on more fascinating topics. Watch the next video on our screen. Thanks for watching, and be sure to subscribe to AI Tech Underground for more exciting videos on tech.